Good afternoon, everybody. I hope you still have some energy left. We are almost done with the conference. And my name is Molnar, and I started to work with Rails in 2012, and then in 2017 I became a certified penetration tester. And today I'm going to talk to you about the OWASP top 10 for Rails developers. I saw some hands, so some of you already know what OWASP is, but let me explain it to the rest of the crowd. It is the top 10 most common found vulnerabilities in web applications. They update this list every few years, and it has been updated last year. So what I'm going to talk about today is pretty recent. And I'm going to go through the list from bottom to top. So we are starting with number 10, which is mishandling of exceptional conditions. This category includes issues like improper error handling, logical errors, failing open, or any other vulnerabilities caused by triggering abnormal conditions in an application. I have a few examples for you. For instance, in this example, if you look at it, this is a controller where we have an authorization filter, a before action. And if you look at the implementation of the method, you can see that we call our service to do the authorization, and then we do some exception handling. So whatever happens during the authorization, if an exception raised, we just make a log entry, which is actually pretty bad, because if you don't do render, redirect, or return false, the filter chain just continues. So if your authorization service is down, then everything is authorized, which is pretty bad. To mitigate this is pretty simple. You should just use render, redirect, return false, whatever. Never do something like this, where you let the execution chain continue if you do something security related. In this next example, we have a controller where we have two methods, the show and the settings. The show is public, setting is private. We have a before action, so we verify the owner on the settings page, and then a few months later, somebody else adds a new method for displaying the API keys of this profile. This should be private, and the guy forgot to, or the girl forgot to update the before action. Now you are failing open because it's publicly accessible. To mitigate this, you should use except, which is basically you are using a blacklist instead of a whitelist, which is always better, because in this case, if you add the new method, a new controller action, it will be not accessible by default. So worst case scenario, you add something which should be public, and someone is going to complain, hey, I can't access this, I should have permission to access, so you fix that. It's much better than having a security incident because you leak API keys of everybody. And I have one more example for this. And this issue I actually found in a real-world application. Quite big Rails app, not Shopify, but an e-commerce site. And if you look at this code, it is a shopping cart. You can add products to it. You can specify the quantity. And if you look closely, you can add a negative number for a quantity. On the UI, it wasn't possible, but UIs don't matter. You can just send a request, change the request parameters, and you could specify a negative quantity. So you would add 2 products to your shopping cart, set a negative quantity for 1, and that balances out the price, and you could order things for free. To fix this, it's pretty easy again. You just need to call the absolute method on the integer, and then it's going to be always a positive number. Now, the next category is security logging and alerting failures. This one covers basically insufficient logging and alerting, and inserting sensitive data into your log files. Let's start with the second one. The issue with this one is if you put sensitive information to your log files like API keys or personal identifier information. The reason why this is a problem, because your logs are not encrypted, so it's plain text. Usually you store your log files at a third party, so you kind of lose control over authorization, and logs are more relaxedly handled by authorization. More people can access it than maybe your personally identifiable information in the application. The good news is Rails handles this really easily for you. There is an initializer with the filter parameters, and this is the default currently, but you can append anything to this array. If you have anything application specific, like, I don't know, last 4 digits of the credit card, which you don't want to get into the logs or anything like that, or API keys, then you can set that here, and it's going to be excluded from your logs. And the second part of this topic is the alerting failures, which is basically the lack of alerting. So you have your logs, you have your events, but you don't set up any monitoring and alerting on it. So what you should do if you use Datadog, Splunk, anything else, you have the option to set up monitoring and alert on certain conditions. And what I think you should alert at least on is the elevated number of login attempts, whether it's successful or failed. Because if you have a lot more successful logins, suddenly, it means maybe your database, your passwords are leaked, and somebody is just accessing all the accounts. Or if it's a bunch of failed attempts, it might be a sign of a credential stuffing or brute forcing attack, and you might want to block the bot or the person who's doing that. You should also log authorization failures or access denials, because that might be a sign of someone is probing your application, and you want to be notified and act and prevent it. Rate limit hits, also important to be notified about, because you might be under attack and you want to set up Cloudflare or anything else to stop it. And permission or role changes can be a sign of something malicious going on. Integration settings change, like API key generation. Maybe somebody hacked somebody's account and they are trying to get more permanent access, and they are trying to generate an API key for themselves. So you should get a notification and look into what's happening. Or error events, or any business logic-related events which are custom to your application. The next item on the list is software or data integrity failures. This is similar to software supply chain attacks, but it's not the same. And I think this is actually not really relevant for us Rails developers, but I'm still going to talk a little bit about it. And it is basically, you would have this issue if you don't commit your gem file lock, for instance, to your repository, and then during deployment, you are getting a version of a gem which is tampered with, because bundler only verifies not the signature, the hash of the dependency from the gem file lock. If you don't have that, bundler can't verify it. Another issue with this one, it can be another fix to this issue could be using a higher trust policy with bundle, which is the high security one validates the signature on the gem, but I don't think this is practical in reality, because not a lot of gem uses signatures yet. Hopefully in the future this will change, but that's what we have for now. But as I said, I don't think this really affects Rails applications. And another integrity issue could be, anybody uses something like this, message verifier in their Rails apps? Okay, I see only one people, that's what I would expect. This is a very low-level thing. You usually don't do something like this. But if you use a message verifier and you generate tokens, you should always specify a purpose, because if you generate tokens for different purposes and is with the same message verifier, you can just use the same token, or the user who uses the token can use it for multiple purposes and might be used for a purpose which is not intended for that token. So always specify, like in this example, a purpose for the message verifier. And this next one is really relevant for Rails applications, because almost all Rails applications have some sort of authentication. And there's a bunch of things I'm going to cover here. The first of such issues is the insufficient prevention of automated attacks. For instance, credential stuffing, brute forcing. But again, the good news, Rails got your back here. We have a built-in rate limiter since Rails 7 or 8, I think 8. And it's pretty easy to use. You put this call into your controller. You can specify how many number of requests you allow, within what duration. It acts like a before action, so you can specify only or except to run this only on a certain controller actions. And you can also, with a Lambda, you can set what should happen when something or somebody reaches the rate limits. It's super easy to set up. But you might want something more sophisticated. Then you have Rack Attack, which is a pretty good gem, pretty old, pretty stable. It has more features than the standard Rails rate limiter, so if you need something more fancy, this is highly recommended. The next item is the permitting the users to set weak passwords. Now, I have this password validation rule here. The password must be at least 10 characters long. It needs to include an uppercase letter, a lowercase letter, a digit, and a special character. Can I see some hands who thinks that this is a sufficiently strong password validation? Only a few. Wow. Guys, you are amazing. You are amazing because admin 1234 exclamation mark. 10 characters, uppercase letter, lowercase letter, digit, special character. This is not a strong password. This is a very weak password. This password is in multiple databases, which people use to brute force or accounts or use for credential stuffing. And the best way to validate passwords is not to validate for specific characters and whatnot, but to use a complexity validator. And there is such validator called ZXCVBN, which is it's basically an algorithm. There are various implementations in JavaScript. There are a few in Ruby, so you can choose whichever you want to use. And I highly recommend to use this one instead of validating for character numbers and whatever. Another thing I highly recommend is the pwned gem. What this does, it validates the passwords against leaked passwords databases. So if your customers are using the passwords and they use it somewhere else that got leaked, then whenever you run the validation, it will flag that as an insecure password. Super easy to set up both of them and very high return of investment, in my opinion. And OWASP also mentions that you should encrypt passwords, but I don't think this is relevant for us. I never in my life seen a Rails app with plain text passwords, so I think it's kind of old. If you have plain text passwords, what are you doing in 2025, right? And the next item is the lack of multi-factor authentication. The reason why this is important, because even though your users might use strong passwords, they use a password manager, they are following all the best practices, they might fall for a phishing attack, and then their credentials get leaked, and somebody is trying to access their account. A second factor will prevent that, and it's really helpful. And Rails has multiple solutions for this. I have a few recommendations. For instance, one is don't use SMS codes. Swim swapping is really easy in multiple countries, or most countries. It's better to use a TOTP-based, which is like the app in your phone, the authenticator, or a hardware key, such as a YubiKey. In my opinion, that's the most convenient one, because you just touch the key and it completes your second factor. And this is also, in my opinion, a low investment, high return improvement to your security. And another important thing is the password reset flow. There are many applications. When you reset your password, you complete the flow, and it automatically signs you in. And quite often, the developers forget to enable MFA on that one, so you are automatically logged in. For instance, Device, by default, does this. When you don't change your defaults and you add the device two-factor authentication gem or anything which is not custom written, what happens then, multi-factor authentication is enabled, but during the password reset flow, it's just skipped because device signs the user automatically in, and then the second factor is not asked for. So if you use device and device multi-factor authentication, I highly recommend to look into that setting. And the next authentication-related issue is section fixation. Rails gets your back here. The important rule is to always reset the session when somebody signs in. Otherwise, they might have a session set by a malicious actor, then they sign in, and the malicious actor has the session key, the session identifier, and they can just take over the session. The reset session method, super easy to use. If you use your custom authentication flow, you should just call this whenever there is a login attempt, a successful login attempt. Now we are on to the next category, which is insecure design. This category is basically the lack of secure development lifecycle and not thinking about the unhappy part of the features. Most of the teams follow some sort of a development lifecycle, which is you plan, you design, you implement, you test, you deploy, and you maintain. And the important part is to have security as a core part of each of these steps. So for instance, during the planning phase, you should think about the security aspects of the feature. What do I need to pay attention to? And then during the next phase, you should involve your security team or champion during the design to make sure they chip in, because they might have better ideas than you how to implement the security requirements of the feature. And then the next step the implementation, you should make sure you follow secure coding practices. And you should also make sure that you look into the specifics of Ruby and Rails, because it has some quirks which you should know about. And you should also make sure that you have test coverage for the security aspects of the feature. And handle always the unhappy parts as well, especially in the test, because then you are kind of covered. And during the testing phase, your QA team should test the security aspects of the feature and make sure that everything is the way it should be. And then during the QA, you make sure the security requirements are met. And during the deployment, you should run some static code analysis, and you should run some vulnerable dependencies check. This is, again, pretty simple in Rails. Newer versions of Rails are coming with a default GitHub Actions file. You don't have to use that, but you can look at it and get some inspiration. By default, it runs a bundler audit, import maps audit, or yarn audit, depending on what you use. It also runs Brakeman for static code analysis. And it's, again, a really low investment, high return. Brakeman can catch these silly mistakes. Vulnerable dependencies can save your ass if you are running any of those checks, so it's highly recommended. And the next item is injections. This one includes SQL injections, NoSQL injections, cross-site scripting, and command injections. Active Record is pretty good at preventing SQL injections, but there are still a few methods, like these, which shouldn't be ever used with direct user-supplied data, because groups, select, active record calculations, calculate, and all these shortcut methods, count, sum, average, minimum, and maximum, are prone to SQL injection. If you directly pass user control data to any of these, you have a SQL injection. And there is also another thing called second-order SQL injections. What this is basically when you are getting the data from the user, and you are storing it in a safe way in the database, but in a later process, such as a background job or something, you are passing the data into an unsafe active record method, such as the ones I mentioned earlier. I have an example for this. This is, again, a real finding. I found this during a penetration test. The application had a reporting feature. You could create a report, and during report creation, you could specify what column you want to group by and which columns you want to see on the report. This is all fine. And then you went to see the report, and on this page, they directly passed the data I just controlled in the previous step in the select and the group call. So all I had to do is to create a report with a payload for the select column, and then I opened this page, and I had a SQL injection. So always make sure that user-controlled values are not used in these unsafe SQL queries. The next injection is XSS. This is, again, really well prevented in Rails. Most of the things are escaped by default. There is one thing which I still find. It's a bit amazing. It's the link to. It's the second parameter of link to follows the HTTP spec, or the HTML specification, excuse me. And that means that you can specify a URL scheme. And actually, there's a URL scheme called JavaScript. So if you have an application where you allow the users to set their website URL on their profile, and they can set it to a JavaScript payload, and then when anybody clicks on that link, then that executes the JavaScript into the browser. I also found this backlink issue, actually in one of the open source Rails apps, which is well known, where the backlink was coming from a URL param, and you could set that to a JavaScript payload, and that was ending up being an XSS vulnerability. But the rest of Rails, like, everything is escaped by default. You should always just be careful when you explicitly use HTML safe or the double equal sign to output anything in your ERB files. And the next injection attack is command injection. So this one happens when you pass user-controlled data to any of these methods: system, the backticks, exec, eval, open, or IOP open. If you have to do such thing, you need to call a shell function with whatever user-supplied data. The best use the Terrapin gem. This one uses argument interpolation, which is quite safe, and it's pretty easy to use. It's from ThoughtBot, so it's a well-known company. I think this is a really good gem to use for such things. Moving on to the next item on the list, it's cryptographic failures. I think we are very lucky in Rails because cryptography is handled for us. Cryptography is very complicated. I'm terrible at it myself. I don't know much about it. It's very math heavy, so it's not something which people like to do. But Rails has active record encryption, super easy to use. All you need to think about is if you want deterministic or non-deterministic encryption. The main difference is if it's deterministic, then it's not as safe, but you can search it. But for anything like super sensitive, you should use non-deterministic, obviously. And regarding crypto, you might need secure tokens or secure passwords. Rails got your back. It has amazing helpers, super easy to use, all handling timing attacks and everything for you. You don't need to think about cryptographical issues at all. And the next category is software supply chain failures. Not the one we had last year with Ruby Central. That wasn't one. This one is more when you are deploying vulnerable dependencies to your production servers. Oops, what's going on with my slides? Yeah, so also, this issue might be when you don't upgrade your Rails or Ruby version when there is a security release. Security releases usually only contain the patch for the security issue. Nothing else changes, so you are usually very safe to upgrade. It's not going to cause any issues, so I highly recommend to always update your Rails and Ruby version when a new release is out, for a new security release is out. If you want to be notified about this, there are mailing lists you can subscribe to, and then you get a notification. I recommend to, if you use Slack, to have a Slack channel where all these releases are coming in, and then in the morning someone from the team can have a look and see if it's relevant for you and just do an upgrade quickly. Or the other issue can happen is that one of your dependencies is vulnerable. This can be a Ruby dependency. You can use bundle audit for that. Super easy to set up. And you can have a JavaScript dependency which is vulnerable. You can use import maps or Webpacker. Whichever you use, you can use import maps audit or yarn audit. And one more important thing about this, I highly recommend, most teams are shipping code every day, so you have pull requests going on all the time. But some teams don't. And I recommend to run these audits on your master branch once a day, twice a day, so you get notified if something is vulnerable and then you can act on it. And the next item is security misconfiguration. This is also pretty rare in Rails. What might happen is that for whatever reason, debugging anything, you enable development features in your production application. For instance, verbose error messages, which can contain sensitive data, or anything like that. But I don't think this is very common in Rails. Probably nobody does this. But you should still know that you shouldn't do it. Which happens actually more often is that you add an engine, like the Sidekick UI or Mission Control or Blazor or whatever, and then you forgot to set up authentication or authorization on this. So somebody can access them without permission. And now we reach the final item, which is broken access control. This is the thing I think, yeah, I found the most. This is what other people find the most, according to OWASP, but this is the most common issue, authorization problems. I have some examples, like this is from earlier, failing open, which is when you basically don't have any authorization. You just forget to do authorization on some endpoints. And that's not so common. I think that's the least common. Then this is way more common. In this example, what's happening, you can create a document, and then the uploader is set to the current user, so we are all fine. That's safe and secure. But if you look at the document params, we permit the company ID, and we don't verify anywhere that the current user has permission to that company. So a malicious actor can just set the company ID to another company and create records in another account. It's not a massive issue because you don't access other people's data, but if your customers would see that something is created in their account, they might raise questions. Hey, are you really paying attention to security? So it still makes sense to worry about this, in my opinion. And this is, again, something I found recently, actually, in an open source Rails app, a real-world example. It has an admin user class, and it can have 3 different admin user roles: moderator, maintainer, core. And then you look at the admin user policy, and you can see that the core user has higher privileges than the maintainer one. It can change role, it can activate users, deactivate users, reset to multi-factor authentication, and whatnot. And the maintainer user can invite users. So then you go to the actual controller when the invitations happen. It uses device. And if you look at the permitted parameters, then one of them is the role. So as a maintainer, I can just send a request and invite my other email account with a higher privileged user permissions, and I just elevated my privileges. Oops. Yeah, and now we are at the end of the list. This is all I wanted to share today. I want to thank the organizers for putting up this amazing conference. Also, thanks to all the sponsors. Without them, we wouldn't be here. And thanks for all of you for coming and listening to my talk. I hope you learned a few things. If you want to learn more about me and security, you can follow my blog, my Twitter, and also if you have any questions about anything I mentioned or just want to chat about security, come and talk to me. I'm very approachable. I don't bite unless you are food, which you are not. So just come and talk to me. And thanks for your attention. Thank you.